So go ahead and draw your unit circle on here just once. I know I have it on the board behind me, but just go ahead and draw it one time because there is actually one slightly different thing about tangent and cotangent. So fill in your points, your up, down, left, right. And the only difference for tangent and cotangent is that instead of the period being 2 pi once around the circle, it's only 1 pi. We're only going to go halfway around. So what happens is you have these little rest stops at the pi over 4 mark. So let's see who remembers. I've had you fill out so many unit circles. What is the coordinate point for that pi over 4? It involves 2's. Good. Good, we got there. Square root of 2 over 2, comma, square root of 2 over 2. I'm not going to make you write that in all 4 quadrants, okay? But the one over here, the difference would be what? Yeah, you'd have a negative. So I'm just going to write it for those 2. All right, and I'll add it to that one in just a second. All right, so that's the only difference. Instead of going the whole way around, you're only going to go halfway, and so you have these little rest stops. Tangent of 0. Tangent is y over x. If you want to write yourself a note, tangent is y over x. So for this first one, 0 over 1 would be 0. 0 over 1 would be 0. Pi over 4, you'd put this over this, which I know looks crazy, but anything over itself is 1. Pi over 2, you would have 1 over 0. You can't divide by 0. So undefined. At 3 pi over 4, we're right here. Anything over itself is 1. It's just going to be -1. And then at pi, we're back to 0. And for these ones, we're going to go backwards. So negative pi over 4 would be right here. That would give you what? Good, -1. Negative pi over 2 would be down here. That's going to be undefined. Can't divide by 0. Negative 3 pi over 4 would be right here. This one is kind of a little tricky. What would that one give you? Good. Why +1? Good. They're both negative. Negatives cancel. And then negative pi is the same as positive pi. It's 0. We're just going to take that information and put it on the grid. It's no different than what we've done before. You're just going to get a different shape of the graph. So we're going to start at 0, 0. And then at pi over 4, we're at 1. And then an asymptote for the undefined. And then the next one's -1, and then back to 0. I know that looks very disjointed, but here's how the pattern's going to go. Because all of these are just patterns. -1, 0, 1, asymptote. -1, 0, 1, asymptote. -1, 0, 1, asymptote forever. So you can go ahead and fill that in each direction. Just follow the pattern. And sorry, I'm trying to draw it fast so I can get my hand out of the way because I know you can't see through my hand. But it'll look like that. Go ahead and put the points and the asymptotes on there, and then I'll show you how to connect it. I like these ones. They look kind of cool. And so when you connect them, you get these like wiggly shaped things. You get like an infinite number of them. Everyone always wants to say that they're cubic. They're technically not. This is a trig function, not a cubic function, but I get why people say that. That's exactly what it looks like. It looks like an infinite number of cubic graphs. They technically aren't, but that's what they look like. And then we're going to write the same stuff that we have for all the other ones. Again, I want you to keep these sheets for the parent functions because then you can compare and contrast these. First thing we're going to do is domain and range. All right, so domain, it's everything except where the asymptotes are. Do you remember writing this last time for the secant and cosecant ones? It's all x not equal to, like a no parking sign. Do you remember where we start? Yeah, it's either 0, if that's where the first asymptote is, or like the first positive one. So where's the first asymptote for this guy? Pi over 2 is the first one. And then it's plus however often they happen, and they are occurring every pi units. So plus pi n. The n takes care of infinity. Every pi, you get another one. You catch a break with the range on these ones, because if you sweep downwards to upwards, what's your range? Everything. That's like an automatic answer. It'll just be all reals, which is cool. It is discontinuous because of all the asymptotes. So yeah, there's a jar on my desk right there. It's like the take a penny, leave a penny jar. You can just take what you need. All right, this one is an odd function. Again, I'm bringing that up because it's going to come up later. It's symmetric to the origin. If you look at this part right here, do you see how this reflects across the origin down there? Like if you kind of just look at that part. Anyway, it's just true, and you're going to need to know it later, so I'm bringing it up. The amplitude, just like with secant and cosecant, is none. So it's another automatic answer. It's like a gimme answer, but you have to remember it. An amplitude is only for a wave. So only sine and cosine have them. And then here's the only real big difference. The period is just pi instead of 2 pi. So I don't know, maybe put like stars next to that one or something. That's the only difference. For tangent and cotangent, everything else you do like usual. It's just the period's pi instead of 2 pi. You only make it halfway around. Yes, exactly. So when we go to do the problems, it's pi over whatever instead of 2 pi over whatever. This is going to be the exact same thing, except how do you get cotangent from your unit circle? Good, x over y. I've woken you guys up. This is going to go more smoothly. All right, so when you start at 0, you would have 1 over 0. What's that going to give you? Undefined. So start with undefined. And then you're right here. What's the next one? 1. And then you're at the top of the circle. Good, 0. Now you're in the second quadrant. -1. And then undefined. Now when we go backwards, negative pi over 4, that's going to be in the fourth quadrant. That'll be -1. And then 0. And then +1. And then undefined. So again, we're just going to take that information and put it on the grid. This one starts with an asymptote. So your first asymptote is on 0, which is actually kind of nice when that happens, because when you go to write the domain, you just start at 0. And then the pattern for this one goes 1, 0, -1 asymptote. 1, 0, -1 asymptote. So that's what you can do infinitely in both directions. 1, 0, -1, and then another asymptote. So it looks a lot like tangent, except what do you notice is different? Yeah, it's like flipped. Like it's decreasing instead of increasing. It's going the other way. I have to confess, I like drawing these ones better than secant and cosecant. I think they're easier to draw than all those little like U shapes. So again, we're going to state all the same stuff. First, domain and range. So the domain is everything except, and then where's the first asymptote? 0. It's on 0. It's nice when it's 0. Plus, however often they happen, and again, they're happening every pi units. That's going to be the period of the function. Like whatever gets written, what you're adding on, that's the period of the function. Range is everything, which is nice, and it's discontinuous. This one is also odd. They go together. So like sine was odd, so cosecant was odd. Cosine was even, so secant was even. Tangent was odd, cotangent is odd. And if you look at this, do you see how this part reflects across the origin down there? Like, I don't know, do you see it? Amplitude is what? None, which is great, but you have to remember that. And then the period is just pi. Again, that's the only major difference.